So for today, we are starting our review for the test. In fact, today is going to mostly cover everything. Not everything, but mostly cover the things that you'll be tested on. We believe at this point that the test will be on Thursday. And the nice parts about that are if we did do it tomorrow, it'd be a shortened day because it's masked. Even if it's not a shortened mask, because if there's also, if the snow that we're having coming in today goes into tomorrow, then they end up doing we're going to rearrange the scheduled day again. So it's going to happen Thursday, no matter whether we have snow days or not. That's one of the key elements here is, like, if we end up getting a snow day at some point, that we're still testing on Thursday. Okay, so, but we have plenty of time then to get ready.
What if
all right.
Harrington event on Wednesday afternoon?
Well, okay, barring unforeseen solar events. Yes.
What if we have a snow day on Thursday?
I just don't think there's anything predicted for that. So
Okay, what if I do a backflip on Thursday? Next week I'll have the
If we
test
have
off.
2 snow days in a row, won't the 6th-hour pre-cal classes not get the review?
all right, so we're going to not go through every possible thing that could happen. I'm aware.
Walks into the school.
Oh my gosh, we're definitely calling off
Has to
school.
take their pre-calc test.
Okay.
Can you just give us an 100?
This one is one of our many properties. Would you agree that that one has a nice easy answer, and it is? Good. All right, so then what if I change this 3 to a 1/3? Now what is it?
-1.
Yeah, because that could be written as 3 to the what? And therefore the answer is -1. Okay, the next one, y equals ln of 4. What's that equal to? That's true. And that's a good thing to do, because what if the problem actually had an e here, then you'd be like, oh, now I see the bases are the same, and then what would the answer be? 4. Okay. I know I fundamentally changed the problem there, but my point is whenever you see an ln, what should you write? Log base e. What if you see a log that doesn't have a base? What base is that? So, for example, if I had 10 to the log 4, you got to go, oh, that log has no base. So, therefore, it's all about the base. And what's that? Base 10, and therefore, what's the answer? 4. Okay, good. All right, a few more properties. Log base 7 of 1.
0?
I won the argument. And I get nothing. Okay, good. What about log base 7 of the square root of 7?
Or 1, no.
Think, don't say it out loud. Think. The answer to this is a number. Don't say it. Think. Write the answer down that you think it is, and in a moment, I'm going to have you compare it with the kid next to you.
Oh, it's 1.
Boom.
All right, compare with the kid next to you and see if you know it. How many of you came to the conclusion that it was 1/2?
Okay, yeah, that was me.
All right, because you are correct, because that is really, the square root of 7 is really 7 to the 1/2 power. You got to understand fraction powers and negative powers in this unit. All right, one more thing. Where could that 1/2 move to? The front. Does it have to? No, but sometimes it's handy if it does. And then if it did move to the front, do you get that that would just be a 1 there next to it? This is just 1, and then 1/2 times 1 is 1/2. All right. Now, I know that many of you have had your cell phone stuck to you full time since you left school. This is the part where those need to go away. If it's out on your desk, put it away now. And in your backpack, please, not just in the crack behind your iPad. Nobody needs a cell phone on crack.
Okay. In the future, do you think
All right.
robots will actually be able to use,
Next thing I'd like you to do is log base 3 of 9y squared over x to the 3rd. That is an expand problem. But usually they say expand and condense.
that a 9?
Nope, I'm wrong. Expand and what's the other word? Simplify, there we go. Everybody expand it and simplify it. And a lot of you will expand it, but you won't expand it all the way. Or a lot of you will expand it all the way, but then you will forget to simplify. Got to do both, expand and simplify. I was a critic.
Hey, my handwriting is worse. I just wanted to make sure.
That is a 9. All right, I'm going to pause for a second while you try this one. And when you're done, compare with the kid next to you. So here we go. I hope you broke this into log base 3. And I like to think of this as splitting it into 2 parts because of that fraction right there. That makes it a minus. So I have 2 log base 3s so far. One of them is 9y squared, and the other one is x to the 3rd. And since it's a divide, this is a minus. Do you see how I got that far?
Wait, can we have
Good.
a couple, like 3 more minutes to do this?
Okay, yep, I'll pause for a second. All right,
A little slow, that's
so next part is this needs to break up, and I'll have Mr. P. Can you help us break this up?
Log base 3 of 9 plus log base 3 of y squared.
Nice, that is broken correctly. It's just not done yet, as I'm sure you know. So can you actually finish the deal now?
Log base 3 of 9 can be rewritten as 2.
That is just a 2. Because this is 3 squared, and then the bases are the same, so the answer's already there. It's a 2 plus. How about the next one? You didn't notice that, did you? All right, Sylvia, what's the next one?
2 log base 3 of
2
Oh.
log base 3 of y. I would have had to cry a little bit and mark that wrong because you have to put that out in front.
That's more simple.
I know, I get.
It looks the same.
I do feel bad because sometimes that's what it takes to get a kid from an A to a B. Like really, it's like, oh. Now, so anyway, bottom line, if everything else was perfect, maybe I could have done a, like a 5% off, but we already have a pretty generous grading system, so every extra mistake, it hurts. So be careful. And last but not least, the same thing, that 3 goes down in the front, 3 log base 3 of x. Raise your hand if you had that one completely right without any help. Okay, good. That was called expanding and simplifying. All right. What else do you have to know? Oh, so many things. All right. Let's try one of these. Log base 2 of x plus log base 2 of x plus 1 is equal to log base 2
This is too complicated.
of 2.
Wait.
I got this, guys, don't worry.
Hint, you want to start with condensing. See, this can be condensed. I'm going to pause for a second and give you some time to try this. Okay, to start with, you should have known that this was log base 2 of x times x plus 1. I'm putting the x in front here. It could have been at the end. It wouldn't have mattered. And then if I have log base 2's on both sides, you can remove them. But there's 2 ways to go from here. Would you agree that's also just 1 over there? So you could have done a rewrite then. 2 to the 1 equals all that. Now, if you don't want to do that way, you can go, okay, I'm going to just ignore these log base 2's. And I effectively get the same thing a little faster, actually. So I kind of like the cancel the logs. It's not really canceling. It's just saying the arguments are equal. And then from here, you knew, because I said so, you got to set the quadratic equal to 0. And then if you can factor it, you should. So go ahead and do that and finish it off. Give me the final answers. Pausing for a second. Do you have x squared plus x minus 2 equals 0? Factor it. You get x plus 2, x minus 1. 2 answers. X equals negative 2, x equals 1. How many of you caught it without Jada telling you that doesn't work? Raise your hand if you caught that. Okay, good. Why? Why doesn't it work? Because in here, when I put the negative here, in the original problem, here we go, in the original problem, and I put a negative right there, it doesn't work. Now, this is an important point. If you had put the negative in this at this moment, it actually would have worked. So which is it? Well, I actually read up on this over break. If there's one form in which it doesn't work, then it doesn't work. Okay, so this one, it looks like your negative 2 is fine because when you multiply it all out, you get a positive. But if there's any form in which it wouldn't work, so that leads to this. If you end up with getting an answer, let's say to something like this,
I have a problem.
I think this will work though. No, that's not going to work nice though, so hold on a second here.
I have one for that.
But I want it to be simple. So if I get two answers to this, let's just keep it simple. If I get two answers to this, x equals one thing and x equals another, let's say it was x equals 10 and x equals negative 10. Do you get that if I put the negative 10 here, I thought we're fine because it's getting squared. I was wrong. I checked it over break. If, since this 2 can move to the front, do you get then it wouldn't be being squared and then having a negative here is not allowed? So that negative 10 is not allowed, period. If either of the two forms you could write it in causes it to fail, like by moving the 2 here, it causes it to fail, then that one's out as extraneous. Does that answer your question well enough?
Yeah.
Okay, good. So if it fails under any circumstances, then that one is extraneous. Okay, so we need to move on. I have a lot of topics. If we have time at the end, I'll happily address more. This one is about graphing. So let's say you had log base 4 of x plus 3. They could ask you to tell the domain and range of this. Well, hint, the domain wouldn't be that hard. You could think that through. But the range is really complicated unless you see the graph. So since you have to graph on this test anyways, would you please find the domain and range, but only after you have graphed it? To graph it, you're going to use an XY chart, and I'm going to recommend that you set this thing equal to 1, because then you won the argument. Not putting a 1 in. That's not what I mean. I mean, make this equal 1 by putting in a negative 2. Make this equal 0, because that finds the asymptote. Make this equal the base, which you can see, so you should know. And make this part equal 1 over the base. All right, I'm going to pause for a second while I give that a try. Okay, so here's some thoughts. It's okay. By the time I'm done, you'll probably be done. So just keep working. I put in negative 2 because then I would have a 1 in the argument. So I'm going to show you over here. I get log base 4 of, when I put in negative 2 right here, I get log base 4 of 1, which gives me 0. So negative 2 comma 0. Another one is, if I get a 0 to be in the argument spot here, then I've found the asymptote. So I want a negative 3 going in, makes it log base 4 of 0, and that's the asymptote. Next up, I want to put in a 1, because then I've found the base. I'll have log base 4 of 1 plus 3 is 4, and log base 4 of 4 is 1. And then last but not least, I actually like this method, so pay attention. If I want this to be 1 over the base, as in 1/4, then I just go off to the side and say, I really wish that x plus 3 equaled 1/4. And that tells me to just subtract 3 from both sides. And if I use x is negative 2 3/4, that's how to get a really weird x value. But it's perfect, because when you put that in, you have log base 4 of negative 2 3/4 plus 3, which works out to 1/4. And log base 4 of 1/4 will be negative 1. That's the hardest but really important point to get. How many of you got that one? I'm curious. Okay, good. So now if I sketch this quick, here's my asymptote at negative 3, and I know logs always go like this unless they've been reflected or something. And now you'd find that this thing, oh, something's wrong with my graph. Because I'm looking at negative 2, 0. I'm good there. Negative 3 is the asymptote. I'm good there. 1, 1. Well, I guess it all depends on how you define 1, 1. I guess it goes through 1, 1. That's maybe I made my turn a little not quite sharp enough to hit 1, 1. Okay, good enough. And then negative 2 3/4, negative 1 is like there-ish. Yay, I've got my sketch. Now, what was the goal in the first place? To find the domain and the range. The domain does not go forever. It goes up to that asymptote and then over. So that's from -3, not touching -3, to infinity. And then the range is, well, that one goes forever. It goes this way, and that's all reals. I'm putting a big R. -infinity, comma, infinity with a parentheses would have been fine. Yes?
What kind of situation would the range not be all reals on a logarithm graph?
On a logarithm graph, it would be very unusual. I can't think of a situation. That's probably because it's the domain. Remember how these switch?
Yeah, when you find
The-
the inverse, then the range is not.
So the domain of a exponential becomes the range of the log. So let's just talk about that for a second. Without even thinking about it, do you get, we now have a domain and a range, which can tell me the domain and range of the inverse. Do you get what I mean? If I just need the domain and the range of f-1, do you guys remember that thing? I'm not just like taking a side trip here. This is important. Do you get if I say f-1, that means the inverse of? What if I wanted the domain of the inverse? The range of the original one. What if I wanted the range of the inverse? Domain of the original one. Okay? All right. So many things to talk about, so little time. The next one I want to jump into is log base x plus 3 of 4 equals 10. A lot of people are going to make a critical mistake. See if you are able to avoid it. Pausing for a second. So, here's a little bit of help to see if you got this far. You should have asked yourself, if you can factor it, you should. Is there any factoring that would make any sense here? No. Is there any clearing of fractions? No. Then the third thing is, during this unit, you always look to rewrite. How many of you knew we should rewrite it? Raise your hand if you did. Okay, good. Then it's x plus 3 to the power of 10 is equal to 4. So how do you fix that? You put it to the power of 1/10.
Oh,
You put it to the power of 1/10, because 10 times 1/10 makes it 1. But did you notice that we just did an even root, like a square root on both sides? Therefore, absolute value is important. Did anybody even catch that? We just did the square root on both sides. Did I warn you that we were going to have that over and over in this class, where you end up square rooting both sides and therefore needing absolute value? Now, I know 4 to the 1/10 power is extremely small. It's like something we wouldn't want to have to figure out. So we're going to leave it as 4 to the 1/10, because on this test, you will not have a calculator. Then this breaks into two things. X plus 3 is 4 to the 1/10, and x plus 3 is negative 4 to the 1/10. Now, we can subtract 3 from both sides, and we pretty much have it. I'm just going to put it right here to save myself pain and suffering. And there's my two answers.
oh.
Yes? Oh, I thought you were going to be like the kid who's like, "Oh, I caught it, Mr. Server," but no. Can I go to the bathroom? Before you leave,
Yeah?
you got to wait and hear the big gotcha. This one doesn't work. Know how I can know? Because they're both negative, and therefore it's -3 and a little bit more than -3, like -3.5 or something like that. And if you go back here and you put in a -3.5, do you get it wouldn't actually work? Because you'd have a base that's negative. Dang, this thing is so complicated. Aren't you glad it's not tomorrow?
Screwed on the test.
Now, could you be careful with something like that? Of course you could. On a test, there's only 4 R3s, 4 hard problems. This would definitely have been an R3 level question. So there'd be 4 questions like this. Could you take the time to really look close to see if there's a negative in the answer, and therefore maybe it's going to crash the original? Yeah, you could. You could have figured that out.
Wait,
So why doesn't it work? Because this
I
would be negative and bigger than -3. So therefore, the base becomes negative. Question, comment?
I do understand that, never mind, sorry.
Okay, good. All right, any other questions? Yes.
So would it be
Yes, you may go. What?
Would it just be extraneous or would it just be no, it just doesn't work?
Well, there's two different, if it doesn't work, it is called an extraneous answer.
Oh, okay.
This one would work.
Pat, can the base be 0? Can the base be 0?
The base cannot be 0, and neither can the argument. Let's talk about those for a second. That's a valid question.
Be 1. Or wait, no.
Log base b of a, do you agree that I chose letters that are appropriate for the positions? A for argument, B for base? Well, B cannot be 1. That's the weird one. But A and B both have to be greater than 0. A has to be greater than 0, B has to be greater than 0. But B cannot be 1.
Why not?
It's an extra rule about logs. You can't have a 1 down here because you might have a situation like this. Log base 1 of, let's say, 3 equals what? And then you'd be like, well, 1 to the x has to equal 3. And then you'll play with it for a while until you figure out that's not possible. So you can't have a 1 in the base. All right. Any questions about that? Yes?
If it was log base 1 of 1, would it
No,
be
no, no.
different?
That's like an exception to any rule. But that's kind of like saying when you take 2 squared, you don't multiply this times this. Well, you happen to do that in the case of 2 squared, but you don't want to make that your rule that you can always do that. No, that only happens to work with 2s.
If we were to be given log base 1 of 1, what would we write?
There is no solution if you have a base of 1. It's an imaginary question. There's no answer. Okay, next up is, let me think. Word problems.
Oh, no.
Oh, yes. No, wait, before word problems, I got one more stretcher here. Log base 14 of
Let's go log base 14. Sure.
10 to the log 14.
You're cruel.
Oh, it's really not that bad.
I don't know.
Base. Well, no, it's not.
And all of that is to the 15th power. It's really not that bad. Okay, now don't say the answer to other people, please. Let people figure it out for themselves. Just to clarify, this part right here is a power. Okay, that's a power on the 10.
Is that log 14 or log base 14?
Yeah, your post hurts.
This is a base 14 right here.
I think I do.
But the power, is the power log?
That is a
Is
base.
it log? This is log base. Take base 10.
I think it's log base 10.
There is no base here.
Got it.
Yes.
I'm pausing for a second. No written base anyways.
Like, this is so
Okay, we need to get going.
Why did they make you-
How many of you knew that the answer came out to 1?
Me.
All right, good.
Oh, it's lying.
No,
Here's,
I'm not.
quiet please, quiet. I'm happy that there's excitement and jocularity, but I need your attention. So this is a base 10, and if these are the same, then the answer to it is just that 14 right there. So this becomes a 14. The whole thing right there, that becomes a 14. So then it's really just log base 14 of 14. And then that's just 1. And then it's just 1 to the 15th, which is 1. Okay, so I skipped a step in there just to be clarify. It was log base 14 of 14, and all of that is to the 15th. I can bring that down to the front of it if you'd like to see that. I could do that, but it doesn't really change the answer because that's 1. So wait a minute. No, I couldn't bring that down to the front. Why can't I bring that down to the front? Because it wasn't on the argument. That 15 was on the whole thing. So no, that wouldn't work. Sorry. That was not correct. So that 15 cannot go down there. So it's just 1 to the 15th like I wrote here. And 1 to the 15th is 1. Okay, now we have word problems. So let's do it in terms of snow. So imagine a world in which the amount of snow is starting with about, looks like 1 inch out there. Okay, so I should have a way to put that into a equation. You start with 1 inch. And let's say it's growing. by 300% every 2 hours. That every 2 hours really makes it harder. Can you write me an equation like y equals 17 times 1/2 to the x plus 4 or something? That is not it, of course. But can you write me an equation like that for this word problem? We start with 1 inch, and we get a 300% increase every 2 hours. I'm going to pause for a second while you ponder that and try. Okay, I'm sensing a lot of challenges, so I'm going to help you. Try to focus here. This 1 inch is going to go right there in the starting position. You put a 1 right there. And yeah, 1 times anything will disappear, but let's leave it there for now to remind you that's where you put the starting number. Then 300% increase. If you put that here as a 3, I pity you because you were close, but you're wrong. It's 1 plus whatever growth you have. And the growth was 300%, so it's 1 plus 3. So there should be a 4 there. It's a very easy mistake to make. The growth goes here. It's always 1 plus in there, yes. So if you're going to time something by 2, it doesn't have 200% growth. If you time something by 2, it has 100% growth. Think about that. If you had 4 and it goes to 8, you didn't just get 200% growth. What would 100% of the original be? It's like you add another one of it. So therefore,
That's confusing.
I know, it is. All right, so next, it's every 2 hours. Your time has to be divided by 2. Who remembered to put the time divided by 2 up there? Okay, good. So now that I've reminded you that that's how it works, imagine for a moment, since I'm talking about today, that we need to get 6 inches of snow to have them call school off early today. Would you please solve for x? If we want to get 6 inches of snow for them to call off school for today, would you please figure out what x would have to be? And yeah, your answer is going to have logs in it. I didn't just say 6 hours. If I did, you'd have put it under x. So I think most of you are smart enough to go, oh, 6 is the ending value. It goes there. And 1 times anything just disappears. This really isn't that hard, as long as you know how to handle logs. Write your answer within 30 seconds, and then please compare with the person next to you.
So you would have
Jada
to
did
read
it the same
each
way.
one. Okay, so you have to read each one.
Oh my god.
Log base 4
You skipped E.
of 6 equals x over 2 times by 2 on both sides. You get a 2 here and a 2 here, and that cancels. And 2 log base 4 of 6. Raise your hand if you had that one right. Awesome. Okay, now we're going to do it with that given formula.
Would it be
Same
wrong
thing
if I
we
wrote
got. We just said
log base 4 of 36?
You could put that 2 up here. That'd be okay. Yep. So back to the given formula. Do you remember that deal where you'd have a start value and they called it like a sub 0 for the starting amount? And then you times by e to the kt? All right. I'd like to do the same exact problem, except this time I want you to do it where you solve for k. We have 1 inch turning into 6 inches over a time that we don't know, and a k that we don't know.
How do you know which equation?
Okay, so I'll give a little help here. That's where you put the start value. This is where you put the end value.
Of K over
And now let's give you one more thing because I think it's a little more realistic to the problem. Let's say that in order for them to call off school for today, that we need to have accumulated 6 inches by 3 hours from now. By 3 hours from now. So then you can put in a t also, right? Please solve for k. We're starting with 1 inch right now. We need to end with 6 inches. if we get 6 inches by a time of 3 hours, what's K? Okay, here we go. So we're going to put in a start value of 1. Shh, focus, please. And an end value of 6. And it's e to the time is 3k. Now, you could say k3, but a little more professional to say 3k. Now, I'm going to ignore that 1 because it doesn't really do anything, and it would save me a step. Now I'm going to go log base e of 6 equals 3k, and then I'm going to put a 1/3 on both sides, and that cancels off this, and there we go. Raise your hand if you had k. Cool. We would never ask you for that. What we'd ask you for is what's the equation now?
What?
Use the same equation,
No.
but what's the equation now?
You have to
So now you don't-
plug that whole thing in for K.
You have this info. You already have that info, but now you know what k is.
That's disgusting.
Wait, I thought it was-
Yeah, honestly.
You are pure evil.
A of t, false. A sub 0 is, oh, it's got to have the same starting value too, in case you didn't know that. We can't just change the starting value, but we can change the ending value. E to the k, which is 1/3 log base e
Oh, that's weird. I don't like that.
of 6. Okay,
Whoa. Whoa.
Times 3.
Marks, you get 6
What?
it's times t.
Why do you hate that?
I'm so happy.
6
That
equals
is
6.
bad.
And then that t can go to the front.
6 equals
All right.
6. This is revolutionary.
All right, so I'm not going to even simplify it from here because of time, but I would have accepted this answer. This is the equation with the k put in, and that is good enough. All right, do that worksheet tonight. Can't make you, but it'll be smart. The worksheet is called Chapter 8 Extra Practice, and it starts with problem 1, which is log base 3 of 27xy to the 4th.